So my name is Amit Kushwaha. I am a director of AI engineering at Samano Systems. Samano Systems is a full stack AI company. And when I say full stack, I truly mean full stack. We have our own chips, just like the GPUs, and we build a whole stack on top of those chips. And what we do is we enable open source models running on these proprietary chips and expose the APIs using the cloud or enterprise offering. Before we jump into Samanova and open source, just wanted to start with what's happening in the AI space. Why is open source catching up? And how does Samanova provides a differentiated capability there? So the first thing that you'll see is here what I plotted is something called an artificial analysis index. So this is a measure of how good a model is in solving complex tasks. So the higher the bar, the more intelligent or more capable a model is. The second thing is you see different colors. So the black color is closed source models. So the models which we don't know much about, OpenAI's model, Anthropic's model, these are all, if you've heard about these names, these are all closed source models. The blue ones are the open source models, where either the research labs or the companies which have made these models available, they've also shared the weights of these models. So you can actually run these models wherever you feel like. You don't have to be dependent on the specific company. And what I'm trying to show here is if you see the gap between blue and black, it's catching up. This is the recent open source model that was released by OpenAI. And you see the best closed source model right now is from OpenAI also, but this is a closed source model. We don't know anything about it. The only way you can access that model is via an API. So the first thing to take out from this slide is that the open source models are catching up. The second reason why you might be interested in open source compared to closed source model is first you can fine tune these models for your own data. So if you're trying to solve a specific task, you can actually use your data and fine tune these models and make them work for your specific task. What it enables is also higher accuracy. So you might get even better accuracy than what you are seeing, for example, with ChatGPT or any other closed source model for your specific tasks. The third thing is you can control the privacy and deployment now. So you can control where you host these models. You can control what kind of data is allowed and not allowed. And this is all under it could be on-prem or it could be off-prem. So you don't have to worry about privacy and deployment. It's fully under your control rather than a third party. The fourth and important point is managing cost. And I'll show you a chart here on the bottom here, where you can compare the cost of an open source model hosted on Samanova Cloud versus a closed source model by Anthropic. And you see the price difference here. Compared to 22 cents, you are actually paying $3 for 1 million tokens there, and same thing for the output tokens. So cost is another thing. The last thing you gain is the open source community, which is continuously evolving, continuously adding more and more functionality, continuously innovating, and you get all those things out of the box if you're using these open source models. And now, why is cost that important? And again, the AI market has been evolving very fast. Just for a couple of years, you can see we started with something like ChatGPT, which is a simple chat model. You would ask a question, and the model will respond to your question. We started evolving from that simple chatbot example to actually, now you can upload your own data set. You can upload your own PDF, you can upload your own document, and you can start asking questions from them. Then you evolve to something called chain of thought, which is basically the model, before it answers to you, it actually thinks within itself. So it will make multiple calls within itself, trying to reason what it should answer. So that increases the complexity even further. And now what you're seeing in this space is what is called agentic systems. So this is not just one model. These could be multiple models talking to each other and trying to solve a much more complex task, reaching out to the internet, reaching out to your documents, reaching out to your drives, getting all the information and working together to get you an answer. So the speed becomes very important. Whereas in the first case, you were just talking about a single model, how you ask a simple question, what's the capital of England, and it will tell you London. And from that simple model to actually all the way here, where you can ask very vague questions, give me the AI policy for UK or something like that. It will go out, search the internet, look for all the documents that are relevant to it, come back and synthesize all this information and come back with an answer. So within 2 years, it has evolved from a very simple chat-based interface to actually much more complicated problem-solving interface. And this is where what the other thing that matters is speed now. A simple example, you can think of it, if a model takes 5 seconds to respond to your answer, what if I'm making 10 calls to the same model? Now, to solve your simple question, it might have to make like 10 calls within itself, to reason itself, to go and fetch the internet and come back. So a simple query which might take 5 seconds compared to now, if you're making 5 requests and there is one model which takes 1 second versus another model which takes 10, which takes a single second. Now you're talking about 5 seconds versus 50 seconds to complete the total task. And these things start accumulating. And this is where the agentic system that I showed in the previous slide and why the speed actually starts becoming more and more important for these more complex workflows. So this is where I would say Samano comes in and tries to solve this complex problem of how would you enable these open source model running at really fast latency, really fast speeds to get your workflows in a real timeline. So I'll show you a link of Samano Cloud in the end, but what we provide is all these open source models, all the way from Meta to Mistral. And if you're in this community, you must have heard about a bunch of these models, which are becoming more and more popular. And all these models are now running on Samano hardware. You can go and log in to Samano Cloud. It gives you free credits. You can try it out. And you will see the speed difference compared to what you will see in the existing infrastructure using GPU. Now, this is a little bit of a hardware slide, how we make it possible. I won't go into too much detail here, but this is the place where we differentiate how what we call RDU, reconfigurable data unit, is different from a GPU, which is the typical hardware that is used to run most of these models. Just 2 key characteristics that differentiate RDUs. First is what we call a reconfigurable data flow unit. So high level, what happens is you are making less movement in and out of the chip, which gives you much more performance. Second thing is a 3-tier data flow memory. So instead of having a single memory on the chip, we have 3 tiers of memory, some memory on the chip, some memory in HBM, and some memory in DDR. So this is what makes possible, first of all, the high inference speed, and second of all, many more models sitting on these chips now. And I'll show you an example afterwards. Happy to talk about this afterwards. Someone is more interested in learning more about the hardware, but this is the high-level picture of why RDU is differentiated from GPUs and how we make these very fast inference speeds possible. Now that chip is packaged together as a whole rack. This is what we call a node. Each node has 16 chips within this, and I'm talking about some of the power characteristics there. You can run this in 18 to 15 kilowatts. The whole system is air-cooled, and you can have multiple models sitting on this single node, enabling your agentic workflows, which typically require more than a single model to achieve your task. We have, and I'll show you another slide of all the integrations we have with the third-party ecosystem. The third-party ecosystem is evolving very fast. We want to leverage that. So we have made it super easy for you to go and integrate into the third-party existing ecosystem. And this is just a high-level slide. If you want to think about agentic applications and the way you want to think about in terms of how it gets orchestrated is you start with a simple objective. You might give a very high-level question to your model. You can say, send me a research report for XYZ, whatever you are interested in. Typically what happens is there is a large model which looks at your vague question, breaks it down into steps, and plans like what are all the things I need to do to answer these specific questions. Once that is done, a number of small models might pick up each and every task from that list and start executing in parallel. And then towards the end, all of these information comes back and gets fed into probably a larger model which synthesizes all this information and finally responds to your question. So a few things that you note here, you need a large model and you need many of these models running together. And that's where I would say Samanova's hardware especially differentiates. We first of all enable multiple models on a single node. On top of that, these models are running at really fast speeds, so really world record-breaking speeds on these nodes. And as I said, this is the whole list of partner and ecosystem, how we are actually working with all the existing third-party tools. You might have heard a number of them. CreoAI is a very famous or very popular framework used to build agentic workflows. MLAI is also another one, is based out of Oxford. You must have heard about LangChain, Llama Index. So the number of integrations in different categories, all the way from voice integrations to low-code platforms, coding assistants. And these should directly work with one of our systems. On top of that, we have open sourced a bunch of GitHub repos where we even showcase how these different workflows can be enabled using models running on our hardware. We have examples of financial analysis. You can go and see how we can look at the financial data and come back to you and give you a response specific to financial domain. Something similar on the data analysis where you can upload your CSV file or an Excel file, and actually the agents go back, do a lot of analysis, generate a bunch of plots, and come back to you and then take your feedback and can go back and make more plots or actually answer your specific questions on that data set. And then same as code debugging tools and other. You have third-party integrations where you can use Samanova's API on tools like Klein, Cursor, all these things that you have heard about. Before ending, I just want to give you a real-world use case. This is one of our customers, Maitai. And the use case that they had was they provide inference as a service, mainly to enterprises. And the difference here is that their enterprises typically have fine-tuned their models on their specific data set. And they want to run these models at a very low latency, so very fast speeds and tokens per seconds. And each customer has their own specific model because these are being trained on their specific data set. So these, maybe the architecture is same, but once you train it on a specific data set, the eventual model might be different based on the use case that this enterprise has trained the model on. The other thing is a large number of their customers use voice applications. And if you know anything about voice applications, latency becomes very important. You don't want to wait for your response after you talk to your device. And that's where I would say latency becomes specifically important, and our high tokens per second speed becomes very critical there. And then they have built complex agentic workflows on top of these. So our solution was basically we took these what you call fine-tuned models that these different customers have and made them run fast on our hardware. And this is where we can have multiple of their checkpoints. What we call checkpoints is basically a fine-tuned model running on a single node. So we can host on the order of 10 to 20 fine-tuned models on a single node and have them work very efficiently. And so, yeah, this is just a comment from their CEO. And the main result here is that my customers were able to see very low latency, so very high tokens per second speed, and along with that, very high throughput. And this was all possible on Samanova node, basically running all these models together on a single node. If you want to go, you can go and actually take a scan of this QR code or actually directly go to samanova.ai. It will point you directly to our cloud where you can go and test out different models running at very fast speeds. And I think you get around $5 of free credit when you log in, and you can go and test out all different models on this website. And with that, I'm open to any questions you have. Thank you.